Okay, second talk, one after the other. Most of you were here, right? Anyway, we do visual testing. I love testing. I'm going to talk about testing as part of this talk. If you want to hear about visual testing, come talk to me after the talk. If you don't stay here, you won't hear about it at all. 4 pillars and a base, the nuts and bolts of a microservice project. Like 2 years ago, all the talks about microservices, so you were probably fed up with why microservices. I'm not going to talk about that. I'm going to talk about the how, the structure, if you want, of a microservice project, and not so much the whys around it. This is the visual grid. It doesn't really matter. Lots of microservices, databases, talking to each other, either via HTTP or via message queues. Not very, well, it is interesting, but I want to talk about how we built the visual grid as in structure. This thing will probably be relevant to most. We have another microservice project coming on at Applitools, and we're using the same structure. But first, why did we build it? Why is the structure as it is? And there are 4 pillars, and we'll talk about the base in a second. But I want to talk about my most, I love talking about this, dynamic languages versus static languages. A show of hands, how many people here work in like Java, C#, a statically typed language? Okay, dynamic types like JavaScript, Clojure, etc. Not bad. Oh, I thought, oh, those guys are like waving really, really high. We all know there's no friendship here. This is war. It's like tabs versus spaces. We have all kinds of static type languages and all kinds of dynamic languages. And static language lovers say that dynamic languages are scary. And they're right. You can't trust the code. You cannot trust a call you're making to another class because there's no type safety. And it's very difficult to comprehend because types are a type of communication, of documentation. There is none. Don't trust dynamic language code, say it's static language lovers. And they're right. They are absolutely right. But dynamic typing, it's my favorite quote. Dynamic typing is not a weakness to overcome, but a strength to take advantage of. And I will add some hypnosis so that everybody will be hypnotized by it, all the Java people. Just joking. And I want to talk about my daughter. And you'll soon see how it connects to dynamic languages. She's 12. I love going out bowling with her, but she loves the bumpers. You know, they go up, and then wherever she throws, it goes bump, 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 and it finds the things and the end. One time we came, and there were no lanes except one lane, and it did not have bumpers. And she said, let's go home. And I said, no, come on, try it. And in the beginning, she tried it, and it was really, really bad. She kept going down the lane, the edge there. But after a while, she started getting better because she was careful. And once she started being careful, you could see that her throws were much better than the ones using the bumpers in the lane. Yes, you can see where I'm going. And dynamic language is just like the non-bumpers. They force you, because they're scary, they force you to be better. It's a psychological argument against static typing. I love static typing, by the way, but it's a psychological argument, but that's fine. We're humans, most of us. And you can't trust the code. So what's the answer to you can't trust the code? And the answer dynamic languages give is very simple. Test it. Test it as much as you can because there's no safety net. There's no bumpers. Difficult to comprehend, so write small packages. Loosely coupled small packages. Each package is very, very simple to comprehend. We're good, even if it's in a dynamically. So they force you to write tests and to build loosely coupled small packages. And those are 2 pillars of the philosophy behind the structure of our microservice projects: testing and loosely coupled small packages. The next 2 pillars are there to help the other 2. It's mono-repos, where all the code is in one repo, and uniform packages. We'll talk about that later. And these 4 pillars enable enable the base. I call it frictionless development. It's where the development is very, very frictionless, where you're writing code and it goes quickly to production without any friction whatsoever. Well, not a lot, at least. Let's start with the monorepo. We're going through each and every one of these pillars and understand it. Monorepos. First of all the source code is in one Git repository. Remember, our code is divided into microservices and packages, like library packages. Each microservice in a non-monorepo, each one is their own Git repository. We have one monorepo for all the microservices. And this is it. It really is applitools/mono. And all the packages, the microservices and the library packages are in packages. That's a subset of them. And we currently have about 75 of them after about a year of development. So as you can see, we have a lot of small packages and microservices there. But why? Why one repo? Remember, we have many small packages, and remember, we need frictionless development. If we had 75 packages, small, each one with their own Git repository, we would be constantly pulling and pushing, and searching through these repositories would be hell. It would be very, very difficult. But if it's all in one repo, searching, pulling, pushing, doing all that is very simple. I'm not demoing, sorry. I did the live coding last talk. I am exhausted. Packages are written separately, totally separately. There can be no code use as in source code use. We can see that they can use each other using import, but not through using regular source code usage. They are tested separately. Each package is tested separately, and they are published to the NPM registry and to the Docker repository separately. Each package is separate. What happens when I have a feature spanning 2 packages? That happens. Well, I first write, test, publish one, and then I write, test, publish the other. That's very, very simple. But what if I want to, develop them together? That happens sometimes. I use JavaScript to have npm link to connect the 2 and test them together. I don't want to get into it, and then I publish both packages. npm is our bridge between packages. If it was Java, then it would have been Maven. So I can communicate between 2 packages. I think you would call them modules in Java. I would communicate through the Maven repository, never through source code. And you would not believe it, but 2-package development is not very common. Most code is written in one package and uses one package, and that's about it. And I said it in the previous talk, Visual Studio Code workspaces are the bomb for exactly that. I can have lots of projects. Each of these is a package in my repository, and each one from Visual Studio Code's point of view is totally separate. They're not one big source. They're many, like as if Git repositories are many projects, each not connected to one another. So Visual Studio Code workspaces deliver really good developer experience in that manner. Advantages. It's very simple to move between one package and another. If I need to see code, if I'm writing a package and then suddenly I want some code that I know will be used by another package, then I create a common package. It's that easy. It's like 5 seconds. Create a common package, put the common code inside it, test it, publish it, and then I can use it in the other package. Very simple to use. No need to create Git repositories and CI/CD and all that stuff. Simple to maintain all those many packages. One push and one pull. It's simple to split. Sometimes the package becomes too big. It's good enough for static type languages, but dynamic, it's starting to become bigger. No problem, we split it. And then we go to all the packages and refactor whatever we need to make that split happen. And as I said, common packages are really easy to develop and maintain. There's not one big, most of you know the big utils module or utils package where you dump everything common inside it and it's grown to be a monster. We have about 20, 25 utils like that, each one in its own specific area. npm link isn't very good. It's bad. That's not good. And CI is a huge problem because most CI tools assume one Git repository, one project. That's a problem, a big problem. And those advantages are what help with frictionless development. I can move code around, I can use it, I can create comment. Everything is very, very simple and very, very frictionless. Uniform packages. And remember, a package can be either a library package or a microservice package, and we'll see both. Mostly microservices because this is a microservice talk. Who knows who said this? All happy families are alike. Each unhappy family is unhappy in its own way. Come on, you live next to the big bear. Tolstoy, there we go. Anna Karenina, it's the first sentence. I have another quote. All happy packages are alike. Each unhappy package is unhappy in its own way. Yeah. And all our packages are very happy. They are uniform. They look very, very similar, and they are uniform in the way we build, test, and publish them. They are the same, mostly the same in their folder structure. That's theoretically optional, but in practice, they are the same. Let's talk about build uniformity. That's the more important thing. First of all, what is a package, as I define it, as we define it at ApplyTools? A package is source code that is used to generate artifacts. That is what it is. So what is an artifact? An artifact can be a Maven jar. It can be an NPM package published to the NPM registry. It can be a Docker image, etc., etc. Those artifacts are used by other packages, for example, an NPM library, or in production, for example, a Docker image. That is our definition of a package. Two examples, we talked about library packages, an NPM package which publishes to the NPM registry, or if you're in Java land, to the Maven repository. Or if it's a microservice package, it creates many artifacts. A Docker image, that's part of what the artifact it creates. Configuration values for production and for other staging environments. And yes, an NPM package in the repository. And this is our build cycle. You can go into any packages of ours, run npm install, npm update, npm run build, which builds whatever. If it's a package, builds whatever. It doesn't. If you're a JavaScript, you don't even need to build it. But if it's a if it's a microservice, it builds the Docker image. npm test to run the tests, publish to publish whatever artifact it is to whatever registry you want to, and in the end, we'll talk about that later, deploy. Example from a library package, I won't get into that. Build, I don't need to do anything to build. JavaScript, beauty. And test, I run Mocha tests and run ESLint. Not very interesting. Microservice is more interesting. Build, I just npm run build Docker, and build Docker just builds the Docker image, as we all know and love if we know how to build Docker images. Test is I run all the tests, JavaScript tests. A whole how to test microservices is a whole thing unto itself. And post-publish, I publish the Docker image. Publish will publish the npm package by itself, and post-publish, I will publish the Docker image to my package repository, to the Docker repository, using what version? The same version that the npm package has, and that's the beauty of it. I use npm package versioning to make my Docker versioning work in the same way. We'll talk about deployment later. What are the advantages of this? Developer goes into a package, they know what they have. They know the build structure, they know what they need to do. If they need to add something, they know where to add that. CI, once we have it, will be much easier. And the disadvantages, as I said, sometimes it's like fitting a square into a circle, but most of the time it really works. We talked about build uniformity. What about source code uniformity? And yeah, this folder structure is very similar. I have the src, which contains all the source, the test folder, which contains all the tests, the package JSON as usual in npm land. Yep, the microservice. This is interesting. The src contains an Express app that when I run it, it runs the Express app. But it doesn't. It accepts all the configuration values as parameters. The scripts is what the Docker file runs. It reads the environment variables and passes them to the src, to the Chrome rendering worker thing, as configuration options. This allows me to either use the Docker image, or in some cases, if I don't want to use the Docker image, just use the npm package and run the application without a Docker image. We use both interchangeably. And of course, the Docker file as usual. For debugging, we already have the debuggers set up, so you can just F5 and debug your application easily using the tests. VS Code allows that. We have tests, and we have an ESLint. This is JavaScript. Testing. Okay, we have a rule, at least in the backend. Front end is like so-so. Never, ever, 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 ever run your code locally. Never. If you want to try, if you wrote a feature and you want to see how it works, you can't just run the microservice and use what's the Postman. Nope. Never, ever, ever do that. You wrote a feature, that's it. You can't run it locally. You want to deploy it direct to production and see if it works there? Fine. You probably won't do that. So what do you do if you wrote a feature, a code for a feature, and you want to see if it works? You write a test. That is the only way we allow our developers in the back end, and mostly in the front end, to test whether a certain feature works. And that creates a lot of tests, believe me. Testing, for me, is the epitome of frictionless development. And I want to sound very serious. So an epitome is a person or a thing. This is a perfect example of a particular quality or type. It is the most important thing in frictionless development because I can rewrite a whole microservice. And I did it last week. I rewrote a whole microservice, 3. Kept the tests, ran the tests, fixed the bugs, deployed to production. That's it. It is the main reason our velocity is high. And it's the main reason we don't need TypeScript or Java or whatever statically typed language we have. We have tests instead. I don't know how to write otherwise. I mean, the whole idea of writing without tests is, oh my God, I don't know. I don't know anymore. I lost the ability. I lost the tail. Let's talk about how we test. First of all, unit testing. Unit test, we have 3 levels of testing. Unit testing, we test functions or modules that are mainly algorithmic. No I/O or just a little bit, file system and things like that. We mostly don't write classes. We don't write functional. We write imperative. It's mostly functions. Usually stateless functions, so it's very easy to unit test. And if there's need of mocking, then probably we won't unit test it. Sometimes we will, but probably we won't. We don't have a lot of these. A lot of people know the pyramid. We'll talk about that later. We don't have a lot of unit tests. For example, we do visual testing, so I have to test if an image is blank. So I get the image, I check that it's blank, and whatever. Okay, this is an example of a unit test from our point of view. Integration tests. Integration tests test the whole microservice. Okay, usually it's the whole microservice. Sometimes it's like, if it's a big enough microservice, large parts of it. And remember, microservices are small. It's microseconds. Well, let's not. Sub-second time to run a microservice and to run a whatever database, Redis or whatever it's using, okay, and run them together. It's like sub-second time, so I can just HTTP the hell out of them, test everything together, and not worry about mocking and all that stuff. Our tests run in slightly under a minute for most of the microservices. We have a lot of these tests, and it's our main ability to rewrite a whole microservice, do it right this time, and run the test again and ensure that everything is fine. This is an example. First of all, I run the app. That's app. I give it all the configuration information I need. I tell it to listen to a port, and then I do a fetch. I HTTP microservice and check that the response is correct. Everything in JavaScript, obviously. So this is an example of an integration test. We have hundreds of them, probably. If I need more, if I need Redis along with the microservice, I use Docker Compose. If you were in my previous talk, you can recognize the Docker Compose. And end-to-end, this is what we call the little end-to-end. The end-to-end, instead of taking the app and running it using JavaScript, we're running the Docker image we built in the npm run build process. Why? Because sometimes your application runs, but your Docker image is bad because you didn't write the Docker file correctly. So we do 1 or 2 tests just to make sure that everything is fine there. This is what I call the little end-to-end. And this is the diamond of testing. This is what we believe in. We don't believe in the pyramid. We believe in the diamond. Few unit tests, just for like logic stuff, very simple ones. Lots of integration because we're a microservice. These tests run very, very quickly, and very, very, very few end-to-end tests. So that's our philosophy of. And how do I know I wrote enough tests? I call it the shakeometer. The shakeometer is how I have this thing. It's check how much my hand shakes when I press deploy. So if it shakes, I don't deploy. I go back, write some more tests, and then try the shakeometer again until I'm fine with it. Coverage, all those metrics. Yeah, come on. Shakeometer. Believe in yourselves. Believe in your intuition. Really. Really, you're really, really smart. Much smarter than you think you are. And I have a special package. I call it the big end-to-end package. What I do is I take all my microservices, all our microservices. We don't have hundreds. We're not Wix. And we deploy all of them to Minikube. Okay? Run the real end-to-end tests on the system. Ensure that everything works. And boom. And the deployment mechanism you use is the same deployment mechanism that we run in production. So we're also not only testing the packages together, the microservices together, we're testing that the deployment works and that the configuration values are correct. We don't do it all the times. We're very smart in this, that we know when there's a cross-thing change, cross-microservice change, we run the end-to-end. But if it's a simple bug fix or a really small refactor, we skip the end-to-end. Which brings us, I think, to the last one, loosely coupled small packages. We've basically talked about it. Why do we work with loosely coupled small packages? Well, this helps us. Well, a microservice is a loosely coupled small package. When we took the monolith like 2 years ago, hopefully, if we were lucky enough, and broke it up into microservices, what we were doing exactly that. We broke it into loosely coupled small packages. All we're doing now is just making the effort nicer in terms of development. Because once you have a loosely coupled small microservice or a library package, it's easy to test. And if it's easy to test, people will test. If it's hard to test, people won't test because we're human. If it's easy, they will. And that is why, again, we don't need TypeScript or statically typed languages. We're fine with JavaScript because we're working in small units. That's a pain point, CI. Let's first talk about CI. We have a mini CI, we call it BTP. It's basically a glorified shell script, build, test, publish, which runs the install, build, test. If everything passes, it will publish. Also commit to Git and push and pull and do whatever needs necessary, but it's all run locally on the machine, which is horrible. I know, but it's not that bad in the microservice world. Back in the days, you were not allowed to run your app locally because who knows what you have in your machine that isn't available in production. Or who knows what is available in production that isn't on your machine. You're not allowed to do that. You need a clean environment. But we have Docker now. Docker is that clean environment. And it doesn't really matter if I run the Docker image on my machine. Well, it does a bit, but not too much. On my machine, or in staging, or in production. So yeah, I don't like the situation where I don't have CI. Don't get me wrong. But it's not as bad as it was like 4 or 5 years ago. So that's what it does. It increments the version, the npm version, npm install, update, run build, test, and publish. What about CD? CD is deployment. Kubernetes is a godsend. It's It's difficult to understand in the beginning, but once you understand it, it's a godsend, really. I managed to overcomplicate it because I'm human, but we're simplifying it right now. It's now all Kubernetes template YAMLs. We're using Helm. We're going to throw Helm away. I don't see a real reason to use Helm today. It's every microservice is using the same template. As you can see, it's templatized. There are lots of parameters in that template with default values, and you can customize it per microservice. So you can define the environment variables, container additions, how much memory it needs, how many replicas you need in production for that specific microservice, do a lot of customization. But the template is the structure. So it's not that every developer of every microservice needs to build all the YAMLs for that. No, they're all templatized somewhere. They just need to customize, and usually it's just the environment variables and the memory limit for each application. And how do we deploy? npm run deploy. It's just kubectl apply -f. It's like here are the YAML files after we customize them, give them to Kubernetes. Kubernetes will do its thing, and voila, we're deployed. A little bit more complicated, but not that much. And we deploy. You're probably sick of hearing it like 5, 10, 20 times a day. Not a problem. And obviously, we have rollback. That happens sometimes. It's happened last year, I think, 5 or 6 times. I think one loss of only one downtime in all these 5 or 6 times. All the others, no downtime because Kubernetes and because our system is very, very much self-healing and that it knows how to overcome errors. Okay, I think there we go. Build, well, no, I don't know. This is how we build. We have one mono repo. All the packages are small. They're microservices or libraries, and they're very, very small. Loosely coupled, as we said, and we test each and every one of them rigorously using a few unit tests, lots of integration tests, and very few end-to-end tests. And we have one big overarching end-to-end test which tests all of these together just to make sure that everything's good. And all this enables us very high velocity and what I call frictionless development. So, besides that, I will leave you another 3 things that are totally unrelated to this talk, but I love them. So you ain't gonna need it. Start simple. Don't overcomplicate things like I did with the deployment and Helm and all that. Start simple. Only what you need, not what you will need in a month. Believe me, you won't need it in a month. Usually you will need something entirely different. So Yagni, you ain't gonna need it. Small is beautiful. Small packages, small microservices, small everything. Remember that small is beautiful, small is easy to comprehend, and that is a very, very important thing. And the last one, KISS. Keep it simple, stupid. Thank you very much.